Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, a few weeks ago, we had a topic where we showed you how to take some register-based ladder logic programs that you may have written in the past and convert those to variable-based advanced ladder so that you can take advantage of some of the new capabilities that are available in a variable-based language. Today's topic is similar, but it's a little bit different. Here's the topic for today. Transform your register-based logic routine to a user-defined function block. Well, the difference today is instead of showing you how to take an entire program and convert it from register-based to variable-based, we're going to show you how maybe to take a piece of logic that you wrote years ago or just a little while ago, whenever the case may be, and take that piece of logic that was written in register-based and convert that to a user-defined function block that then you can reuse over and over again in your variable-based programs moving forward. So we think it'll be a highly worthwhile topic. Let's take a look at how we break it down. We're going to start with just a little bit of review on the differences and similarities between register-based and variable-based advanced ladder. We're going to talk just for a few seconds on what is a user-defined function block and what are the advantages. But I guess I would say a lion's share of our program today is going to be talking about the workflow when you're transforming that register-based logic routine into a UDFB, and it's going to be packed full of demonstrations. That's where we're going to be spending most of our time. All right, let's go ahead and get started. In CScape, there are multiple styles of logic programming available. We have a couple different variations on our advanced ladder logic, which is kind of an American-style ladder logic. We've got register-based and we've got variable-based, and we'll compare and contrast those here in a second. But don't forget, we also support the IEC 61131 languages for those of you who prefer IEC 61131, and we've got plenty of videos on this channel showing you how to use IEC 61131. But today we're really honing in on American-style advanced ladder, as we call it. And we're going to really show you how to take some of that register-based logic you wrote before and reuse it again. So let's start with register-based advanced ladder. Now, register-based advanced ladder was the original logic language available in CScape in 1998. And because of our installed base, it's still the most widely used style of CScape logic today. And we don't have any plans to obsolete it. Even though we're adding more modern options, we're not taking away the classic options that some people, frankly, still prefer. There are some disadvantages to register-based advanced ladder, however, because with that language, it requires that all variables that you add to your program have to be mapped to a specific memory address in the program. And that makes it more labor-intensive when you are adding variables to your program. It also makes it more labor-intensive when you are replicating code because every time you copy and paste, you have to go into the pasted logic and readdress everything. It also doesn't support some of the newer features like the data structures and the user-defined function blocks, which we're covering today. Now, with variable-based advanced ladder, you don't have to map all your variables as you add them. You really typically only need to deal with a couple of them, and we'll talk about that here in a few minutes. You do get support for those advanced features. And in our training courses these days, we're teaching both variable-based and register-based kind of in the same course, kind of side by side, if you will. Although in the advanced course, that's pretty much variable-based is the way that one is taught. And it's certainly the recommended approach for new users that are just getting familiar with CScape. If they're looking to use an American-style ladder logic, we encourage them to use the variable-based version for sure. But don't worry, if you're someone who's used the register-based for years and you want to reuse that code, entire programs of that code, you can convert your programs from register-based to variable-based. Okay, so there's the kind of compare and contrast between the two. But let's take a quick look at memory mapping between the two, because certainly, like I mentioned a minute ago, with register-based advanced ladder, you have to memory map every single variable as you bring it in. And with variable-based programming, you don't. Although, if you've got a I/O point, a real-world I/O point, and you want to tie a variable to that real-world I/O point, that's a case in which you would memory map. Also, if you're going to send a variable out over a network like Modbus, for instance, you would memory map in that case as well. But those are the exceptions rather than the rule. Now, the tools are a little bit different between register-based and variable-based when you're creating variables and when you're editing variables. Now, in both cases, you can create variables on the fly, or you can create them in advance. The tools are just a little bit different. User-defined function blocks, which is what we're going to talk about today. These are sections of code that you can take and modularize and turn them into a function block that you can call similar to a subroutine, but really more like a function block. That's why it's called a user-defined function block. Unlike subroutines, with UDFBs, you can have multiple instances in the same program. If you're using a subroutine, which are highly useful, you're going to have one copy of a given subroutine, and you can only call that subroutine once at a time. And it can't have multiple sections of code calling it and being in different areas of execution. That doesn't work that way. But with UDFBs, you do have the capability of having multiple instances of UDFBs in your logic simultaneously. Now, let me give you an example. For instance, let's say you are going to create a user-defined function block to do some simple pump control, and you've got a dozen different pumps in your application. You create a single UDFB for pump control, and then you basically have a dozen different instances of that UDFB for each of your different pumps. So that is really useful. That's something you can't do with subroutines, because with UDFBs, each instance has its own set of variables, whereas that's definitely not the case with subroutines. Lots of benefits to UDFBs, the ability to reuse your code very easily. It makes your programs more organized and easy to follow. Just tons of benefits, and that's why we're covering it today. Let's talk just for a minute. Actually, we're just going to show on the screen what our workflow would normally be to create a UDFB if we're starting from variable-based advanced ladder, and we just want to take some logic we've already written in variable-based advanced ladder and turn it into a UDFB. The procedure is there on the screen, and we have plenty of videos that tell you how to create a UDFB from scratch and those sorts of things. So I'm not going to cover this in a ton of detail. What we are going to cover today in a lot of detail with tons of demonstrations is we're going to help you take a routine of logic that you may have written years ago using register-based logic, and we're going to help you turn that into a user-defined function block that you can use in a new variable-based program. So there's a lot of advantages to this approach that we're going to show you today. First of all, I'm sure a lot of you that have been using Horner products for years and you've been using register-based logic for years, you've probably got a lot of code you've already written and tested that works very well, and you'd like to reuse that if you can. And by reusing sections of logics instead of the whole program per se, the heavy lifting of code creation and testing has already been done. And by taking a section of code, it's fairly easy to turn that into a user-defined function block. So that's really what we're going to focus on today, primarily with demonstrations. So here's the workflow we're going to demonstrate. There's the steps there. Let's kind of go through that real quickly, and then we'll show you in detail every step, and you can show, or I can show you how I took a routine that I wrote years ago and turned it into a user-defined function block just earlier today, really. So we start by isolating the piece of the program that we want to turn into a UDFB. I mean, if we're converting an entire ladder logic program over to variable-based, we can do that, and we've shown you how to do that. But today we're going to show you how to take a piece of that you want to turn into a routine and how to isolate that and then make the conversion. So you're going to isolate that piece of code that you want to turn into a UDFB. You're going to go in and make sure it's documented the way you want. You're then going to convert that little snippet of code into a variable-based program on its own. You're going to go in and get rid of any memory mapping that happens by default when you convert from register-based to variable-based, because we never use mapping when we're using or creating user-defined function blocks. We're going to identify the inputs, outputs, and private variables that we need to specify when we create our user-defined function block. We're going to create that user-defined function block, and then we're going to test it. Let's go ahead and demonstrate this workflow. Now, what I did was I taped my demonstrations earlier today. Because this is a fairly extensive demonstration, I thought it would be easy just to kind of pre-record it. Everything went super well, frankly. I probably could have done it live, but just to kind of save a little bit of time, I thought it would make sense to pre-record it because I could fast forward through a couple of the more tedious steps. So let's start into our workflow, and we're going to go through our process here. And let's start with the first step, which is isolating the register-based code to its core function, and then I'm going to demonstrate that for you, just the core code, how it works in its current register-based form. So our first step is to isolate the code that we want to ultimately turn into a user-defined function block from whatever program it was originally included in, whatever register-based program it was originally included in. And I've kind of done that already. So let me show you what I've done here. So this is my application, which is performing a 3-point calibration while it also scales an analog input to engineering units. So here's my logic. It's only really a few rungs of logic. I would say about 30 lines of code or so that's performed. And you can see it's definitely register-based logic here. And then I have a companion, a screen or user interface. And you can kind of see how it's designed to work. So the whole idea is that in the field, you would have a technician who would fill in the low, the middle, and the high levels that you want to calibrate to, and these would be in engineering unit. So if I had maybe I was controlling the level of a well or monitoring the level of a well, this might be in meters or feet or inches or something like that. That would be engineering units here for a low, a medium, and a high level. And then I would be monitoring, during the calibration process, I'd be monitoring my raw analog input coming in. And then after I was done setting my low, mid, and high levels, after I had done that calibration, then my scaled value would show up here and I could verify the scaling was correct. So that's how my application works. Let's go ahead and download this. Although I think I've already downloaded it actually. Never mind. Let's just go on the bench and take a look and see how it's working. So I'm going to go to the benchtop view. It's always important, of course, that you test any code that you're going to turn into a user-defined function block to make sure it's actually working before you turn it into that block, okay? So I'm going to use, let's say, 2 meters, 7 meters, and 10 meters for my well level here. Those are my engineering units. Those are inputs to my code. And then my current analog value is here. So let's move the analog value up to, let's say, what would theoretically be the 2 meter level. We'll hit set low calibration. We'll move up to what would theoretically be the 7 meter level. Okay, somewhere in that range. And we'll say set that. Of course, in a real application, we would be taking much more care to get exactly to the level we want to get to before we hit the set calibration button. All right, and now that we're done, we're getting the results we want. You can see our scaled value here is working just like we want. So, okay, so that's the application, the code that I've isolated that I'm going to turn into a user-defined function block. So let's take a look at the variables and the comments in our program and make sure we're happy with them. One thing you'll notice is that the IO names that were put in here originally, they reference specific channel numbers and that sort of thing. They're also fairly long. When I'm creating variable names that ultimately will be used in UDFBs, I want them to be more generic and a little bit shorter if I can. I still want them to be descriptive, but I want them to be a little bit shorter. So if we go to program IO names, and again, this is our original program with the isolated code, you can see these are the IO names I'm talking about here. And I think I'd like to rename these variables. You don't have to do this. This is a totally optional step, but I like to do that, again, just to make things a little bit more generic for a UDFB, and in some cases to maybe shorten them down a little bit more. So one of the things you can do in Cscape, of course, is you can copy all your variables and then paste them into Cscape. And I did that a little bit earlier. And let me show you my spreadsheet here. So this is effectively the original, as they currently exist, variable names, or IO names as they're called, with register-based Cscape. And I went and figured out what new names I would prefer that might be better for a UDFB. And I created a new set of names here. And then what I have the ability to do is I have the ability to copy these new names and hit copy. And then I have the ability to go into Cscape and again back to the program IO names area, and I can paste them in. It asks me if that's what I want to do. And now I've got my new names in there. So again, this is a totally optional step, but in my case, I thought it was worthwhile to have some somewhat shorter but still descriptive names for my IO names. So that was the next step that I completed. The next step in our workflow is to convert this register-based logic over to variable-based. So let's go ahead and do that. It's pretty easy. So to do that, we go over to the Project Navigator. We highlight the name of the program, we right-click and select Convert to Variable Based. We hit the Start button. It immediately prompts us for a new program name. Important to give it a new program name. Here we go. Let's give it a new name. Let's go keyboard. There we go. Hit save. It completes the conversion process. Now don't panic, the size is going to be larger, but it's still not going to be a problem. It's still quite small. The extra size is due to the variables. At this stage, it's important that we go ahead and save, because we now have this variable-based program that we want to save, and that's it. So that's that part of the workflow. Okay, next, we're going to actually strip off the memory mapping that is maintained when you convert from register-based to variable-based, because we won't need it anymore when we use this variable-based code. Now, in some scenarios, you want to leave that memory mapping there, but not when you are creating a user-defined function block. There's typically no reason to do that. I'm actually going to close this program that I just saved, and then I'm going to reopen it again. That way, all the options for a variable-based advanced ladder program, including the ability to create UDFBs, will be present, because Cscape knows that this is truly a variable-based advanced ladder program. So let's go ahead and open up the program variable window. Remember, the program variable window is the tool we use to edit our variables in variable-based advanced ladder. So we can go under the global variables, and this is where we see the global variables that have been created, and you'll notice that when we get to here, we've got effectively the memory mapping, and that's what we're going to go ahead and strip off, because we're not going to need that. So I'm going to double click on the memory column, hit the backspace to clear it out, and enter. And I'm going to do that on every one of these variables, and there's only a dozen or so, so it isn't going to take that long. But that's basically the next step in our workflow, and I'll just go ahead and complete this offline. I'm starting with my new program here. I have converted it from register-based to variable-based, and I've already stripped off the memory mapping from all my variables that will be ultimately used in my user-defined function block. They're currently used here in main. Okay, so the first thing I'm going to do is I'm going to create the UDFB by going to UDFB modules, right-clicking, hit new UDFB, and I need to give it a name. I'm going to call it cal_3 Should be a relatively short name, but descriptive enough. So the first thing I need to do is I need to create the variables for my UDFB. Because remember, UDFBs have their own variables. So let's go back to our program variable window, and you can see now that I've created this UDFB, I have a variable group called cal3. Let's go ahead and add a couple variables to it. And we'll do it the slow way to start. So I'm going to right click, hit add variable. I could also hit the insert key. I'll make it an input parameter, and I know that one of my inputs to my function block is going to be the AI in. That is an integer value. Let's add an output. And I know one of my output variables is my scaled output, which is a real variable. Okay, and so I've added a couple the slow way, if you will. I could add all the rest of my variables in this fashion, no problem, but I'm going to show you a shortcut. The first thing I'm going to do is I'm going to go to my global areas. That's where all my variables that I created in my main loop that'll ultimately become UDFB logic, that's where all those variables are located. I'm going to right click and say edit variables as text. And then this allows me to scroll down and find that list of all the variables that ultimately are going to be in my UDFB. So I'm going to copy those, and I'm going to go and I'm going to close it here. And there were no changes made, so it doesn't prompt me to accept the changes. Now I'm going to go down here, right click, and say edit variables as text. So I'm edit the variables as text for my calibration variables. And the reason I put in an input and an output variable was to show you what the syntax looks like. And then I'm going to paste in all these variables that ultimately need to be classified here. Now, the only thing I didn't put in was all the private variables. So I need to add the syntax here for those. There we go. And I'll make room for those. Input variable, AI in, I've already done that one. I'll get rid of him. Low, mid, and high EU are also, those are my engineering units. Those are also input variables. These are all internals. Like making sure these are all, I'm sorry, this one is an output. Let's go ahead and move him to the right section here. Oh, he's already there, so we're good there. These are all internals. So I'll move those there. And these are basically inputs. Let's get those added to the input section. So I've got my inputs, my output, there's only one, and my internals. That's a shortcut for getting all those variables added. Because remember, I'm keeping the same names. That's why I can do that. Now it's prompting me that I've made changes. Do I want to keep the changes? And I do. So now I've got variables assigned to my Cal 3-point UDFB, and there they are. You can see they're all in there now when it's expanded. Next thing I'm going to do is I need to take all this code that I have currently in my main loop, and I want to insert all that code into my UDFB loop. Now, but I've got to have room to paste it in. And if we take a quick look here, we can see, I believe we've got about 30 lines of code. So we got to make sure we have enough space for it. So I'll go back to my UDFB area. Let's go ahead and just go ahead and let's insert 10 lines, and then let's insert 20 lines. So that gives us plenty of room. Let's go back to our main code. I'm going to do a select all, which is Control A for select all. Then I'm going to do a copy, which is Control C. I can also right click and say copy. Okay. I'm going to go to my Cal 3-point, right click and say paste, and then click where I want to paste it. Okay, that's all been added. That's good. So you might think that we're done. Well, we're not done. The reason we're not done is because I've just pasted in code where with all the variable names from my global area. So there's all the variable names from my global area. See, they match 100%. Well, inside of a UDFB, for all the UDFB variables, you need to have a prefix on every variable that is a UDFB variable has to have the prefix of the name of the UDFB. So let's go ahead and add that now. This is another shortcut. I'm going to go ahead and paste in the prefix on all these variable names. The first thing I'm going to do is I'm going to select from the Cal 3-point group the AI in variable, and you can see it put a prefix on here. So now I'm going to go ahead, copy that prefix, and I'm going to paste it with a Control V on every variable in here. Okay? Paste, paste. So I'm going into every function block under every variable that's using a UDFB variable, and I'm pasting that prefix on there with a Control V. Place my mouse, Control V. Place my mouse, Control V. All right, and this isn't going to take that long. I'm going to go ahead and speed up the process so you don't have to watch me do this. But I think all total, this is going to take me probably well less than 5 minutes to do this. Okay, that's done. That wasn't bad at all. All I had to do was go in and add that prefix to all the variables that are used in the UDFB that are UDFB variables. I didn't have to do it on things like always on. Those can just stay the same. But all the other variables, again, the ones that use the UDFB variables, those need to have that prefix. Okay, so that wasn't too bad at all. Took less than 3 minutes. I now have logic in my UDFB with its using the proper variables. Now I need to go ahead and test this. So what I am going to do next is another little bit of a trick here. I'm going to go to my main loop, which has the original logic in it, and I don't want this to execute. So what I'm going to do is I'm going to right click and I'm going to say exclude from compilation. So now this original main routine, when I run my program, isn't going to execute, but I'm going to create a new main loop module, and I'm just going to, I could call it anything, but I'm going to call it test UDFB, just to give it a logical name. Now we're actually going to build logic using the UDFB and make sure everything works properly and test it. So what I'm going to do is I'm going to use an always on contact, and I'm going to call a instance of my UDFB. Now, where do I find that at? Well, if I go to my project toolbox, I can see that there's a section called UDFB at the bottom, and my Cal 3-point UDFB is listed there. So I can drop it down. Now it's going to ask me to name it. So I can give it whatever name I want to give it. I'm going to call it, let's just call it Channel 1 Cal. Well, let's do something a little more descriptive than that. Let's say this is the level of a tank, which is what our example has been. So let's just call it level Cal. So now it's given me the label up there. Now I need to fill in what are the inputs and then the output variables. What are the input variables and all the output variables for my UDFB? Now, the way I've done this kind of creation workflow, I already have global variables with these exact names that I can use as my inputs and outputs for my user-defined function block. So I'm just going to choose those. So I can go ahead and choose those this way from the list, okay, or I can just go ahead and type them in. And shouldn't take me too long. Okay, if I've typed them in properly, they already exist in my global list, so it should just take them. And it did. If it would have asked me if I wanted to create a new variable, that's probably a clue that I typed in something wrong, but I didn't, so everything looks good. Okay, so here is my user-defined function block. To test this, I should be able just to download this to my controller. Now, you may wonder about the screen here, and take a look at that. Let's take a look at my screen. Well, because I use the same variable names that are already defined in my global variable list, and they were already used on this screen that I created, I don't have to make any changes here either. So those are ready to go. So basically, I'm now ready to download and test this user-defined function block. All right, let's go ahead and do the test now. So a couple of things. One thing I don't want to forget is that this AN variable here, if I'm going to actually test it on my bench, it needs to actually be mapped to one of my analog inputs in my system, or in my I/O simulator, in my case on the bench. So down here in my global variables list, this AN variable that I have mapped to my UDFB, or that I have assigned to my UDFB here, I went ahead and added a memory mapping entry for %AI1. So that way we are getting direct correlation between the analog input coming in and this particular variable. The other thing I like to do when I make a significant change to a variable-based program like I'm doing here is sometimes I like to actually clear the memory in the controller before I download the new program. That way we can be sure we have a fresh start in terms of, there won't be any old variable values or anything like that. So under controller, clear memory, this is one of the ways I can do it. I'm going to go ahead and clear my program and my register and variable values. It reminds me that it's going to stop the controller when it does this clear. So now my controller is now stopped. I'll go ahead and do the download. So we'll do the download. And then I have to remember to restart my controller once that download is complete. Not quite there yet. Getting close though. Okay, download is complete. Let's go ahead and restart the controller. And let's head to the benchtop view. So let's set our low, mid, and high engineering units. We've been using 2 for low, 7 for the mid value. We want to calibrate 2 and 10 for our high value. We are getting a value here for our raw input because of the fact we did map it to our first analog input. I'll set it up here to what we're calling our 2 meter level. So that's our low calibration point. I'll set it up higher to approximately what I'm going to call the 7 meter level. Of course, in a real application, I'd be very sure it was exactly 7 meters. And then let's go ahead and go up to what I'm going to call, for the purposes of this demonstration, the 10 meter level. And now we can look at this value, and as our level goes down and our analog signal goes down, you can see our analog scaling is doing exactly what we want. And we've effectively calibrated our analog input with a 3-point calibration method, and at the same time, we scaled it to engineering units. So that's complete. I would do a little bit of extra testing here on my UDFB just to wrap it up and make sure everything is exactly as I want. Okay, now we have one last step I want to show you here after we have completely finished and tested our UDFB, and that is I'm going to export this UDFB so that I can use it in future projects. So I highlight it here and I right click and I say export. It asks if I want to export the module fully protected. I would recommend that you don't do that unless you are at the point where you don't want your user or whoever's using this UDFB to see the logic inside. So I'm going to say no, which means I'll be able to see the logic inside. I'm going to go ahead and give it the same name, Cal 3-point. It'll have an extension of CPU. I'll hit save. And now, the next time I have a new variable base advanced ladder project and I want to use that 3-point calibration method, I can just import that UDFB into my project, and then I have the availability of using that with multiple instances within that project. So if I have 4 analog inputs, I can have 4 instances of that UDFB, and it's just nice and easy to use. So that wraps up our demo. I know we said we were done with demos for today, but I want to show precisely how you import a UDFB into a project. So I'm going to create a new variable base advanced ladder program. It could be an existing one. It doesn't have to be a brand new one. I'm going to import that UDFB into this program because I want to actually use it. So I go under logic modules. I hit right click, import logic modules. I go to the folder that contains the CPU file. I hit star.cpu so that Cscape can find the file. There it is. All right, I hit open. It's showing me the contents of the UDFB because of the fact I didn't protect it when I exported it. And now in my main loop or any other main logic module, I can go ahead and find that UDFB under the UDFB area of the toolbox, and I can place it in my project, name it, and use it just like I would anytime. Okay, so that is our final demo for today. All right, so hopefully you found that demonstration useful. I think any of us who have been working with register-based logic for a long time have a collection of programs and routines that we'd like to be able to reuse. It looked like quite an involved process. I tried to be very detailed, so it's really not as bad as it looks. I just wanted to show every possible detail and give you some hints on how you can kind of streamline your process and make sure everything goes super smoothly. So as a wrap up for today, as we've mentioned many times in this channel, user-defined function blocks are just an amazing feature that you really want to take advantage of moving forward, whether you're talking about variable base advanced ladder or whether you're talking about the IEC 61131 programming languages. It's available in any variable based language in Cscape. And just because you've got a piece of code that you wrote that's been written originally in register-based advanced ladder doesn't mean that you can't turn a piece of that code into a user-defined function block, and we showed you how to do that specifically. So now I want to remind you that we're here every Tuesday at 2 o'clock, either fully live like today with some pre-recorded video content that I threw in there just for today, or whether it's a pre-recorded video that we're streaming live Tuesday at 2 o'clock. We've always got folks standing by to answer your questions in the chat section. If you're watching live, if you're watching on replay, then please give us your comments and your questions in the comments section. Now, just a little while ago, we went ahead and merged our YouTube channel. So now the Horner APG YouTube channel that you're watching right now includes content from both Horner Automation and Horner Lighting. So don't forget to check out our lighting products on the YouTube channel, in addition to all our great automation content. So next week, we're going to show you how to build an analog totalizer with the Horner OCS. So maybe you've got an application where you've got a desire to calculate volume of a liquid or something based on a flow, a liquid flow. And we're going to show you how, if you have an analog style flow meter, how to turn that into a totalization and to calculate the volume of your liquid. So it's going to be a fun techie type session next week. Okay. So if you haven't done so already, please subscribe to our channel. We try and bring you some good content. It doesn't cost anything. And if you choose notifications when you subscribe, you'll also be notified every time we go live or every time we post a new video. Okay, so until next week when we talk analog totalizers, everybody get out there and let's do us some good. Happy holidays, everyone.